Hello everyone, my name is Adam Erbash. I'm a software developer at Trendyol, and in this presentation, I'm going to talk to you about why we chose Couchbase as our NoSQL database and how we use it over here at Trendyol. So first of all, let me introduce myself and my company. Trendyol is founded in 2010, and it is one of the biggest e-commerce companies in Turkey. And it's been growing exponentially for a few years, and it's gonna continue doing that. So there are around 600 people working on tech department, and I've been with Trendyol for a year and a half. I'm with Trendyol's OMS department, which stands for Order Management System. We get around 20 orders per second, and we create over 60 packages per second for those orders and their returns. And at any given time, we have minimum of 150,000 users on our platform. So our agenda is like this. First, I'll talk about what was our requirements for a new database and which NoSQL options we considered and how we compared them and how we came to a decision to use which one. And after that, I'm gonna talk about our use cases in Trendyol, which SDKs we're using, small tricks for smaller documents, and OMS services powered by Couchbase. So we were going to re-platform our claim project, which manages our customers' returns. So we needed a new database, which needed to be document-oriented. So it forced us to go for NoSQL, and it should be easily scalable, and it should be easy to use. So we didn't want any steep learning curve so that everyone in the team can get used to it pretty quickly. So which options we considered? We had 3 options at the beginning, which quickly came down to 2 because Cassandra was not optimized for update operations, which we were to have plenty. So we were between MongoDB and Couchbase, so we decided let's do a benchmark between them, why not? So here we have our sample architectures for our Mongo and the Couchbase cluster. Mongo is a standard classic Mongo cluster, which had its primary and secondary nodes. So you can write and read from the primary, but you can only read from the secondaries. And it replicated data from primary to secondaries to keep them in sync. And on the other hand, we had our Couchbase cluster. We had different services running independently with index, query, and data services. So to test it, we needed some data. So we designed an example document model to test it. So in here, you can see our example claim document, which had its created dates, its items, its order ID to check which order it belongs to, and its statuses, it notes why the customer has returned it, so on and so forth. So we generated 1 million of these documents. Each of them are unique, and we inserted them to each of the databases. So after inserting our documents, to benchmark it, we needed to be able to read from it. So we defined some indexes and the queries to counterpart them. So the indexes, let's talk about them. First of all, we needed to read with ID. It's a pretty simple one. So we will get a random long value and then read from the database with it. For this part, Couchbase didn't need any indexes because it's essentially a key value database and you can get your document with the key. The second one, we wanted to query the deepest possible value available, which in this part was our claim item status histories, and under that we had our claim item statuses. So we wanted to index this part and then have a query running on it. And then the third one, it was a composite index. So it consisted of claim item status, and then the claims last modified date combined. So we can have a claim item, which is in the desired status and which is updated on the given time. And after that, our last one, we will use the query above and then get a single document and then save it back to the DB with an update to an insignificant part of it. So we can have we can check our sample queries to create the index and have a query running on them. So the first one is to create an index on the Couchbase. It seems like this. So this is the name of your index. This is the name of your bucket which you are defining the index for. And these are the parts. So we wanted the last modified date and the claim item status for every claim item in the claim. And on the Mongo, it seems like this. So again, you have your last modified date and your claim item status. And then to query them, this is like an example Couchbase query, which you will have your ID from the metadata and your claim properties. So yeah, it's much more like SQL. It's almost like the SQL, except this part. And on the Mongo, it's quite different from what you experience from SQL and Nickel. It goes like this. So, and more, let's go over there later. Okay, so this is the indexes and the queries. So how did we test them? We've written a simple Java API to process the given queries and indexes. We used Spring Couchbase template to implement Couchbase part of it. And then we used K6 to load test it. And then after that, we utilized InfluxDB and Grafana to visualize the details. So it seems like this. So at first glance, Mongo seems to perform better, but keep in mind that when we were doing this, I had 2 years of Mongo experience and 0 with the Couchbase. So our Couchbase could be more optimized, like with the indexes, for instance. From here, which you can see, I put the last modified date on first and the item status on the next field on the index. But when I was querying it, I was getting an exact match for the item status and the range query for dates. So it could have been better if I had the item status part on the first and the last modified date on the last. So it could perform better, for example. And at the time of our testing, Couchbase didn't have transactions, but Mongo had, so you can see an extra column here. And then after doing the stats and the benchmarking, we came to a decision to which one to use. And as you can understand from the name of the presentation, we chose Couchbase, and here are some reasons why. So the first two simple ones, Couchbase provides you with a built-in optimistic locking, which you can find under the name CAS, which stands for check and set. So in Mongo, you can find this. Of course, you can implement your own solution for this, but it's not nice to have something built in. And moreover, Couchbase provides you with a built-in UI and monitoring. So you can run your queries, you can monitor your nodes, which indexes are used the most, how many operations per second you have on your bucket, which queries are running slow. Like this information, you can find it in the built-in UI of the Couchbase. But on Mongo, you have to go for third-party options to have this functionality. And moreover, even if we hadn't used them, Couchbase provides you with full text services, analytics service, eventing service. So it has more functions than you would ever need. Okay, so to the other points, essentially Couchbase is a key value database. So anything you do with the key and key, so for example, ID of our claim is extremely fast and efficient. Moreover, Couchbase has XDCR, which stands for Cross Data Center Application, and it is bidirectional. So you can have your clusters running on different geographical locations, and you can use them with active clusters. So it is much more flexible rather than the simple Mongo replica and primary architecture. I mean, of course, you can shard your Mongo, but the primary for each shard is a bottleneck for your write operations. And moreover, since Couchbase doesn't have any master-slave architecture, it doesn't need any re-evaluation of its master when it failovers. So it has much lower downtime on failovers when you compare it with Mongo. And one of the things that I like the most is the multidimensional scaling of Couchbase. So as I showed on the former slides, you can have your different services running on your different service. So let's say you have incredible amounts of data, but you don't have to run any queries on them. So you don't have to define any indexes on them. So you can have all your nodes on data services, and you don't need this index and query service. But let's say you have small amount of data, but you have some complex queries and indexes running on them. So you can adjust your services to your needs. And if you just want to add a new service, let's say your data is growing faster than you could. So if your data is growing faster than you anticipated, you can just add a new data service and you're done. You're good to go. And it is so simple to add these new nodes. It's incredible. And when you compare to Mongo, the most common replicas at Mongo, which we use on our testing, has horizontal scaling. So it is much more like a relational database. You have to horizontally scale your master to get a better performance. I mean, even if you shard it, it makes vertical scaling possible, but it is homogeneous. It's not like Couchbase, which you can have different services running on different nodes to your requirements. So multidimensional scaling is one of my favorite things about Couchbase. So another point is the built-in sharding. First, talk about Mongo. Mongo doesn't have built-in sharding. Mongo is optimized for single shard users, so it does not support any join and group operations or multi-shard setups. And when you want to shard your data on Mongo, you have to choose your shard keys for each of your collections, and it is an irreversible choice. So once you've done it, you can't go back. I mean, you can always start over, but who wants that? And you need to shard your data manually. So your development team, or the team which has the most domain knowledge, should choose a key to shard your data, which may not be homogeneous. So it can change over the time. So it's not really flexible. And it's not easy to run like the Couchbase. You have to get your extra services, extra nodes available, and you have to configure them. And it makes your sharded key queries faster, but if you don't have your shard key for each of your queries, it's not really feasible and not as effective as the Couchbase. And moreover, if you go from like a normal Mongo to a sharded one, you have to make changes on your application, which you don't need to on Couchbase. So in Couchbase, you don't need to do anything manually. It just shards the data automatically for you. And data is divided uniformly on each vBucket, which are divided uniformly on each of your nodes. And each server has the same number of active and replica vBuckets. So your load is distributed equally among them. And there are no idle nodes. If a node is joined to a cluster, it is active. It has some vBuckets or indexes running on it. So on the query and indexes part, as I said before, if you don't have the shard key on a sharded Mongo cluster, it does a scatter and gather operation, which is quite ineffective. So it sends the query to each of the shard and collects data from each of them. So let's say you want to get 100 of data from some query. It goes and gets 100 of data from each shard and then aggregates them to return you just 100. And Mongo has its own query language. I mean, yeah, you can get used to it, but most of the developers have some experience with the SQL. So if you go with the Couchbase, Nickel is pretty much like SQL. So it's much more easier to learn. And for your indexes, Couchbase has global indexes, and it's sharded manually, so you don't know which is the shard key, what is the shard key. It just does them automatically. You're not even aware of that. So if you just want to run a query for your index, you don't have to do a scatter and gather operation. Couchbase manages that on your index services. So how do we use Couchbase on Trendyol? We use Couchbase on our Java and Golang applications. We use Java for our business heavy services like the claim. And we use our Golang for the business light services with high throughputs like the storefront read model, which I'm gonna mention later. At first, we used to bring Couchbase template for our Java projects, but then we switched to a native Java client. And my friend on Realmas has written an article about it on Medium, so you can find that and read about it. Why have we done it? What did it provide us with? And another matter, we do some tricks for size optimizing. So we do not write null values on our database. So yeah, nice. You have smaller documents. And you can shorten your property names on the JSON. For example, we had created date, or let's say we have our order ID on the example claim JSON model, which we've seen before. If you just write OID instead of order ID, and you do this for all other properties, you can have something around 25% size reduction, which is quite good, in my opinion. So that the service that started everything, Claim, is our team's first Couchbase powered service. And it's not only key value operations. We have some indexes running on it to see which order has claims, which seller has claims, and things like that. And we actually done a POC with the full text search service on Claim, but we didn't put it into production because we noticed that we don't need it. We can just use global indexes instead of that. So we didn't need the complexity. And another service is Charge. Charge service calculates the promotions and coupons and breaks it down to each order item to how much discount applied on it. And it is mostly key value operations. And at that time, we had 1.2 million RPMs with the average time 20 ms. as I said before, Couchbase is essentially a key value database. So when you get your operations on key value, it's pretty effective and amazing. So another one, we have our read models. So the first one is the storefront read model. This is the service which serves the orders of the customers. So when you go onto the site and you want to see your orders are coming from Couchbase. And we have high updates over this. So each time your packages stats change, order stats change, claim stats change, has a reflection on this database. And it has over like 200 updates per second. And then the customer read their data from this. So we have some optimized indexes for our queries, like we can query with the customer ID and the date that the order is given. And it has around 15K RPM with the average response time below 10 milliseconds. So yeah, quite impressive. And then the next one, which is still in development, is the seller order read model. So we are serving customers their orders through Couchbase. Why not do the same for our sellers? So this project is like that. It's gonna have a little more complex queries than the storefront read model, but I'm sure that Couchbase can handle it. So that's all I need to say. Thank you for your time.